Well, welcome to part 3. In this instalment I'm just going to show how to turn up an end cap using a mandrel. In the last instalment I showed the machining of this end cap here, which I turned up between two discs. One disc which had a piece of sandpaper or abrasive paper glued onto it, so that when you pressed up against the disc and pushed against it from the other side using the tailstock with another blank but with no abrasive fitted, that held it tight in the so that you could machine it. And that, by using that method, you don't have to drill a hole in the blank. So we've got a complete end cap here. Just going to take this out, and this is our completed end cap, and I think that you'll agree that looks as good as any commercial end cap that you'd buy. It's very accurate, fits in the tube nice and snugly. There's no interference fit there, and you get plenty of compression on the O-ring. I mean, that was a little bit difficult to get out because I haven't actually put any grease or anything on there, but you can get it out okay, and it goes in quite easily. And I can assure you that is completely tight. I've checked that, so it's a much better fit than the original. For the second disc, I've already drilled a hole through the centre of the disc, and that hole has been sized for the actual mandrel I'm going to use, which is a 1/2 inch mandrel. And this is the mandrel I'm going to use. It's just a threaded shaft with a spigot on the end there, and this part is mounted in the chuck, and this part, the threaded part here, that holds the work on. But what we tend to do as well is that we put a washer on either side. That will go on there, and another washer on the other side, and then we use a nut here to tighten it up. And when I put this in the chuck, I will tighten this up a bit more so that there's no chance of this slipping. Here we have our mandrel and our work mounted, so that's just going to be mounted into the chuck like so. Chuck key, and make sure that's good and tight. And as I said before, we also use the spanner to make sure that is nice and tight. That is more than firm enough to do the turning that we require. So once again, I'm using the same cutter, which is just a normal side and face cutter. This is a tungsten carbide tool, which is complete overkill. You can actually, if you're machining plastic, normal tool steel is quite sufficient. In fact, you could probably just use normal carbon steel tools, is quite adequate for cutting plastic. The only thing that I would say, if you're cutting any sort of plastics that have got glass content in, and some of the clear plastics they fill with glass to improve the clarity, that will most likely have an effect on the cutting edge of your tool. It will blunt out quickly. So but if you're just using things like PVC and plastics like that, really just normal carbon steel is quite sufficient to cut it, and high speed steel will keep an edge forever pretty much. So it's very easy stuff to cut. So I'm going to just turn this down to get the diameter nice and uniform. Again, taking light cuts. You don't want to take heavy cuts with this, because otherwise you'll probably make the disc spin on the mandrel. You don't get the same level of grip that you do with a normal chuck. So take light cuts, there's no rush. we're not on a shop floor with a foreman looking over our shoulder telling us that we've got to make half a dozen an hour. You can take your time and you're less likely to make mistakes. So that's our disc machine down now, and so the next point that we want to do is to machine the second diameter down so that we've got a step on the end cap. And if you were using axial compression, that would be the only two stages that you actually need to do. You've then got a completed end cap. But obviously, with as we're using radial compression of the seal, we will need to put a groove in as well, which I will do with a parting tool. Now, the advantage with turning on a mandrel, unlike the other method that we had, is that we can actually take our tube and we can test fit it over the actual end cap to see that it fits the way we want it to. And you can see, beautiful fit. Yeah. In actual fact, I would say that's a little bit tight. So I could do with actually taking just a small amount of material off of that, just so that it goes in without any sort of interference at all, so that when the seal's on there we're able to it's just the seal that provides the friction as we push it in, and not the actual plastic end cap itself. I'm just going to spot back on my work to get my reference. Take a tiny amount more. That's it. As you can see, I'm just taking off a whisker off of that surface. Probably no more than about a thou or so. That's a lot better now. That's a good fit in the tube, but there's no interference at all from that. In fact, if you can hear that, but you're almost getting a seal with just the plastic alone. So that's as far as I need to go with that. So, as I said, if you were making an axial sealed end cap, that would be your cap complete. Now you might want to put a small chamfer on each edge, just to get, because the machining does produce a small burr overlap on there. You can chamfer that with a little bit of paper or a small file, or you can actually machine on a chamfer if you want something a bit larger. The next stage is to line up a parting off tool. And like the last end cap, I'm going to go in around about an eighth of an inch, or 3mm in my case, as I'm working in metric. About 1/8 of an inch or so in from the inside edge of the end cap, and that's where I will start my my groove, and then I will move the tool along to widen it out to the required width, which in the case of my O-ring is about 3.6 mil, 3.5 to 3.6 millimeters, and I would have to go down to the required depth, which, if you remember from the last instalment, that was 2.55 to give me my required O-ring compression of around about 10 to 15%. And in the case of this this module that I'm making, because the tubing is not great, I'm actually going for the upper end of that at 15%. I'm going to spot onto the, just touch the tool onto the disc, just to get my reference, my zero reference on my tool. That's it. And then I'm going to zero my dial, cross slide dial on the lathe, and I'm going to plunge in 2.55 millimeters. Two mil, 2.5, 0.55. Back that out now. And in the case of this parting off tool that I'm using, it's 1.5, it's about 1.5 mil wide. I know that I want about 3.5 to 3.6 mil wide, so I need to move the tool along around about 2 millimeters, 2 millimeters along to get my required width, because the tool itself adds some extra width. And what I do is I double check that, because the old carpenter's maxim is to measure twice and cut once. Yep, that looks about right to me. Again, we go in 1 millimeter, 2 millimeters, 2.5, 2.55. Okay, so I've got a small piece in the middle that I haven't machined out because my tool isn't wide enough to do the groove in one hit. So So what I do is I just wind it back about halfway and I go in again. It's 2.55, and then what I do, I just move the tool along a little bit either side of that to make sure that I've got a groove that's nicely evened out. And there we are, one end cap. Groove's about the right width. I'll double check to see what our internal diameter is. If I 2.5. So yeah, it's about right. So I'm pretty much within my spec of what I want there. So all I do now, the only thing left I'm going to do is I'm just going to use a small file just to put a small chamfer on each part. Okay. What's left now is to, with all our machining operations now completed, I can demount the, undo the mandrel and remove the piece. You shouldn't take it out of the chuck or of the mandrel until you've finished all the machining operations, because once you do that you'll never get it, or it'll be very difficult to get it back in alignment again, especially with a 3-jaw chuck. So there we go, just got a little bit of clean up to do there where I marked the cap out, but there is our finished end cap. Here's our completed cylinder. Both end caps set inside the pipe. I've just got this one sitting a bit outside from here. Push that too. I've tested the cylinder. I blanked off this hole in the end here, which was used for mounting on the mandrel, and I tested the cylinder and it's completely watertight, and in fact it's airtight as well. So working a great deal better than the original cylinder. Clearly we haven't got any insides. That would be a topic for another film. But one thing I would like to mention before we finish up is what you would actually do with the pipe, and this is more important really with radial type sealing. So let's take this cap off, because the seal pushes inside the cylinder, the edge on the cylinder itself, the inside edge here, that needs to be free of any burrs, and it needs to have a radius on it, or chamfer, and so that it doesn't cut the soft rubber seal. Now, there are various ways of putting that on. I expect that most people having a go at building their own dive modules won't have a lathe big enough to be able to mount the tubing to machine it up, so they'll be cutting the tube by hand, and then they'll want to finish it off by hand. And an easy way to actually put a chamfer on the inside edge, at least with a soft plastic like PVC, is to just run a very sharp, use a new blade if necessary, and run a sharp knife around the edge of the tubing at about a 30 to 40 degree angle, just to put a chamfer all the way around the inside edge. I've already actually put a bit of a chamfer on this edge, so I'm really just sort of demonstrating it there, but you can see I'm taking a bit off there. It comes off very, very easily indeed. Just take light cuts, obviously take a bit of care because it's easy to cut yourself. Another method, probably a bit safer than using a knife, is to just use a round or half round file, and again at an angle of about 30 to 40 degrees, just file the edge down all the way round until you get around about, I would say aim for around about 1 millimetre of chamfer on the edge, maybe a bit less, so about between 1/64th to 1/32nd, so you don't need a lot. And then you can actually finish that off afterwards if you want to with some abrasive paper if you want to get it really smooth. But to be perfectly honest, the chamfer that you achieve with your knife or with your file is perfectly acceptable. And then what I would do is just lightly get a small bit of grease on my finger, just wipe that round the edge there, just to lubricate that cylinder a little bit, and that helps the seal. When you put the pin cap on, it should go home easily like that. Okay.